So good evening all. So am I audible? Please respond. Am I audible? Okay. So from these three, how many of you attended last week's session or you are new? Okay. So I think all three are new today. So can you just introduce yourself and uh, what is your background and where you are from and means what is your what you are pursuing right now? Can you give a brief account, one by one, shortly, so that I can have a uh, uh, I can have a uh, if I have a brief background, then I can pace my session accordingly. So can you can you start introducing yourself briefly, quickly? Anjan Shyamal, please introduce yourself.
Yes, sir. I am from West Bengal. I currently studied at Ramakrishna Matha Government Engineering College, Civil Engineering, third year student.
Okay. So have you studied soil mechanics before in your college, or this is the first time you are studying?
Now I have studied in my college in soil mechanics in fourth sem and fifth sem.
So
Currently, foundation engineering is my sixth sem. That's why
okay,
I can enroll the integral course of foundation and geotechnical one.
okay. So second one, IST show 4. Okay. The third one, Miss Neha, please introduce yourself. Are you there, Miss Neha? Okay, all right. So we will proceed to the session. So before that, I would like to introduce myself. So I am Yogendra Narayanan. I'm a research scholar at IIT Bombay, the Department of Civil Engineering. So this session will be handled by me on every Saturdays uh, from 5 p.m. to 7 p.m. as you are being notified in the NPTEL website. And unless any changes are there to the timings, we will be sticking to this timing on Saturdays 5 p.m. to 7 p.m. So the major, so coming to the subject, so this is Geotechnical Engineering 1, uh, where we will be, where you are being introduced to the material and its characteristics, its properties, and its behavior to external load will be covered. And these sessions are in addition to the weekly content, actual lectures which are being uploaded in the NPTEL website. So these sessions are especially arranged for the benefit of the learners to practice some questions based on the weekly content, and so that you will be more equipped to face your NPTEL examinations or your university examinations or any other competitive examinations. All right. So, can anyone, how many of you have gone through the weekly content of the NPTEL? Have all of you gone through the lectures, two lectures? Okay. So, can you briefly say what has been covered in these two lectures? Sorry, in this week's lecture? What are all the topics? Please switch on your mic and say. Anyone? Please respond. So, try to respond via mic. So, this session is being recorded, as you all know, and will be uploaded so that other learners who are unable to attend these sessions may also get benefited. So, will kindly refrain from writing in the chat box and but try to speak out. Right. So I expect these sessions to be interactive and kindly be curious and ask questions. So you are free to interrupt anytime during these sessions and ask your questions related to this subject. So please do not come and ask about the assignment questions that are being uploaded. Those things are not entertained here. So essentially, we will be solving the previous year assignment questions, particularly including the assignment questions to give you an idea of how the scheme of the exam will be in the input to get you familiarized with the scheme of the exam. So with this, to give a brief account of what has been covered in the lecture last week. So it has been started, it is, you are being introduced to the formation of soils, some continuation from the weathering process and different type of weathering agents, type of soils, transported residual, and geological classification of soils, and followed by the classification of soils based on their deposition characteristics. So this was being introduced by the course instructor in a very detailed manner. So based on this content, we will be solving some, not solving, we will be discussing some questions theoretically. Since this, so initially 2-3 weeks of lecture, so week 2-3 weeks of sessions would be uh, mostly theoretical or conceptual rather than numerical. So once the actual classification parts and once we start to understand the material properties, we will be solving predominantly the uh, the sessions will be predominantly numerical. All right. So this is the brief background of this session and what you are going to uh, do in these sessions. From your side, you have any expectations of what should be covered or what should be done? Uh, Kindly, somebody can switch off their mic and speak about it. What is your expectation from these sessions? So you are both are undergraduate students, and so what are your expectations from these sessions? Quickly. Pranjal, quickly, what are your expectations? Fine. So we will enter into the session. So at least I expect you to actively participate by at least saying the answers to the question. So as I previously insisted, try to refrain from entering the answers in the chat box. So it will be seen by your it will be as I said, it is being recorded and it will be uploaded in the YouTube so that others learners can also benefit from this. So please switch off the mic and answer so that we can have a fruitful discussion. All right. So I'll just share my screen now. Are you able to see my screen?
Yes, sir.
Okay. So, once again, formally welcome you to this course. The course instructor is Professor D.N. Singh, and this is the second session of the course Geotechnical Engineering 1. So we'll go into the questions directly based on the um, contents of the of this particular week, right? So the first question: which of the following constituents of the soils are considered as contaminants? Answers: which of the following is considered as a contaminant? Answers, please. Okay. So we'll just try to understand what are all the options that are given. So the first option is intergranular cement. So what is meant by intergranular cement? So if you have two grains that are arranged like this, I'm just saying. So in some cases, there will be a part of a part which connects these two grains, which acts as a bridge. All right. So it acts as a bridge between these two grains. All right. So this part which connects these two, which acts as a bridge between these between two grains, connecting it together, is known as intergranular cement, right? So this intergranular cement can be made up of usually is calcite, which is calcium carbonate, and it can be silica, SiO2, silica cement. All right. So these are some of the intergranular cements that exist in this, and usually this intergranular cement are part of the soil system itself, or part of a soil system. It's not due to external agents. So it's a natural process which makes this cement to glue two grains together. All right. So this is not a contaminant. All right. So coming to the organic matter, so it's given that along with the soil water system, organic matter is present due to the living organisms that are present. So you cannot remove organic matter from the soils, at least in the natural form. So it's not a contaminant. And air, coming to air also exists in the soil water system. So it's a constituent of soil. So it is not a contaminant. So coming to the dissolved salts, so you need to understand dissolved salts can be two types. So one is the naturally dissolved salts, which are present in the water itself, like NaCl, or what due to the continuous interaction of water with minerals, there might be some salts that are present, and some salts like heavy metal salts can be leached out from the uh, contaminants that are being dumped over the ground, and they mix with the water component of the soil. So those things are potential contaminants. So dissolved salts, although there are some salts which are inherently present in the soil water, so it has a uh, chance of getting contaminated externally. So dissolved salts is the option for the question uh, which is considered as contaminants. Any doubts? Any doubts? Right. So we move on to the next question. So which of the following constituents of the soils are formed by chemical weathering of rocks? Which of the following constituents of soil are formed by chemical weathering of rocks? Any answer? Any guesses? Means any reason for considering any options? Anyone? So kindly switch off your mic and answer. So you are answering it uh, in your chat boxes, which most probably, since I am presenting in full screen, I may not be able to see your chats. So I am in the I am of thought that you are not responding. So there is a reason why I'm asking to respond via mic. So as you rightly said, clay minerals is the right option as you said. So Now, but however, we will analyze the other options also. So, first of all, primary minerals. What are primary minerals? What are primary minerals? So, primary minerals are essentially minerals like quartz, feldspar, which do not go any significant uh, chemical changes or any uh, changes in the mineral itself. Right. So rocks, there are different type of rocks. These rocks contain some minerals, and once weathering is done, the mineralogy does not change. So those minerals are primary minerals. Examples are quartz, feldspar, calcite, etc., whose mineralogy does not change. And organic matter are essentially they can be decomposed, and it is a biological process. All right, and it's biological weathering. The biological agents decompose organic matter, and the decomposition of organic uh, dead organisms gives rise to organic matter. And coming to vapor, vapor is essentially due to temperature. All right, it's a yeah, it's due to temperature. So it's also a physical process. And primary minerals, these are disintegration. It's also a physical process. It's a biological process. Clay minerals, they form when there is a change in the mineral arrangement itself due to several reasons. So, for example, uh, the formation of clay minerals, montmorillonite, etc., those are chemical changes in basalt. So we will see why how it is what to say, how basalt is giving rise to Mount Molonite and everything in detail in some time. So chemical clay minerals are essentially formed due to the chemical weathering of rocks. So hence the option is clay minerals. Any doubts? Any doubts? So coming to the next question. So which of the following soil types exhibit predominantly cohesion? Which of the following soil types exhibit predominantly cohesion? Which of the following exhibit predominantly cohesion? So what is cohesion primarily? You would have studied in your 10 plus 2 physics. What is cohesion? Or at least you might have come across this term. Yes. So as you rightly mentioned, cohesion is the force between two similar particles. So essentially, the plastic nature gives rise to cohesion, especially in soils. All right. So sand essentially, you can rule out sand. Uh, in case of in its inherent cohesion, it does not exhibit inherent cohesion. Sand exhibits predominantly friction. All right, so this is not an option. Peat also does not exhibit cohesion. It's an organic soil. It undergoes decomposition. So that's also not an option. So marine clays exhibit cohesion. So they are very sensitive materials. So they exhibit cohesion, but the strength of the soils are very low. Once you just, if you touch these clays, they will get disturbed and they collapse. All right. So, but clay minerals usually exhibit cohesion, so kaolinite and marine clays are predominantly cohesive in nature. Any doubts? Any doubts? Yes. So try to answer. So I am not. I am unable to. Uh, it's difficult for me to switch tabs. So kindly answer by switching off your mics. I am saying for multiple times. I don't know what is the reason that you are not switching on your mics and talking. So you were earlier switching on the cameras and everything, but you are now not switching on the mics. So it is making it is really difficult for me to switch tabs so that whether you are answering anything or not, I am unable to check it. So yeah, anything you want to say?
No, sir.
So once you can switch off the mic once while I am discussing, and when you want to say or when I am asking something, kindly switch on the mic and talk. All right. So coming to the next question, which of the following mechanisms are predominant in the granular soils? Cohesion, friction, or adhesion, or both? A and B. So which of the following mechanisms are predominant in granular soils?
Sir, friction.
Yeah. So what do you understand by granular soils? What do you understand by granular soils? You can say whatever is coming to your mind. Don't worry, don't worry that will it be right or wrong. So you are here to learn. So okay. So as you rightly, you were partially right. So granular soils, in case exhibit friction, or you that is right, that part. So granular soils are essentially individual particles which are put together and are binded together by confinement, and they derive the strength from essentially friction. So you might uh, you might uh, you might have come across uh, friction between two particles, or two what to say, uh, you might have drawn free body diagrams and studied about static and kinetic friction and everything, right? So that is what is being done here. So same theory we will be applying it. We will be soon studying it. So then you will be knowing how to. You will be deriving this theory of friction. Uh, how it is being applied to soil mechanics. All right. Any doubts? So moving on to the next question. So sedimentation of suspended particles in water bodies is guided by. Sedimentation of suspended particles in water bodies are guided by. What is sedimentation? You might have studied in either uh, come across in geotechnical engineering or environmental engineering. You might have studied the design of sedimentation tanks and everything. What is sedimentation? And what law governs it?
So sedimentation is a particle settled down to a gravity.
Yes. So once a particle is there in a fluid, what type of forces act on it? So I will just to put it simply. So this is the water column, all right. So the sediments are getting. This is the bed. There are sediments that are suspended in the water column, or it is moving like this. So what type of forces act on it? What will be, you take a particular grain and draw the free body diagram. What are the major forces that act on it? So why centrifugation must occur? Okay. So it's, so when you draw, it is buoyancy force. It's self weight of water. Sorry, self weight of the particle which acts here, and due to the violent flow of the uh, water around this, it is subjected to centrifugation also. So the right option is all of the above. Any doubts? Any doubts? Right. So coming back to the next question, which of the following properties might change during disintegration of rocks in the process of formation of soils? It's specifically disintegration of rocks in the process of formation of soils. Why mineralogy should change? it is specifically given disintegration. It's not weathering, it's disintegration. Disintegration is a physical process. Why mineralogy should change? Yes, but you are saying all the above. So disintegration is essentially a physical process. So essentially it's a physical process, and disintegration is nothing but the breaking out of chunks of rocks from the parent rock. So it will change the density as its arrangement is being changed. Its texture is going to change because it is going to sustain several external mechanical loads. But mineralogy is purely governed by the chemical action. So disintegration does not affect the mineralogy. So you take any, for example, igneous rock, that is granite. It's mostly quartz. Once it disintegrates to sands. So it's just uh, you can just what to say? It's just quartz and quartz. The mineralogy is not going to change. All right. So the options are A and C. Any doubts? What is your doubt? Okay, fine. So we'll move to the next question. Which of the following is an example of disintegration of rocks due to chemical action? Which of the yes. So it's essentially limestone dissolution in seawater and acid rain precipitation in reaction. Why limestone reacts with what limestone does? So what seawater does to the limestone? So what is the pH of the seawater? Is it acidic or basic? It's basic. And basic nature has a tendency of what? If you apply base to your uh, is to your skin, or when you expose your skin to the basic solutions, which will cause itching. That is true. That is only going to happen in this itching. That is in your local terms, which is itching. So what to say? It tends to rupture the rock. All right. So rupture the mineral. So that is going to affect the limestone. It causes what to say, cavities uh, over a period of time. So if you want to learn more about it, you can just search in internet karst formations. Karst formation. Karst formation. Right? You can check in the Google uh, karst formation and where it predominantly occurs. All right. So acid rain precipitation and reaction, that is relatively obvious. Acid tends to dissolve the minerals, some minerals, susceptible minerals. So that also leads to disintegration of rocks, especially by chemical actions. So the right options are A and B. Any doubts? Okay. Coming to the next question. Presence of what makes the lowest to be weakly cemented? Presence of dash makes the lowest weakly cemented. What are lowest deposits? What are lowest deposits? Any answer? How it is formed? What are lowest deposits and how is it? How they are? What is the origin? Yes. So loess are essentially wind deposited soils, and they come under. That is right. It has. It is fine, light-weighted grain. It contains fine, light-weighted grains with, as you rightly mentioned, sharp edges. And since they are deposited by wind, they come under Aeolian deposits. So these Aeolian deposits usually are accompanied by weak cementing agents, which are essentially calcite. All right. In the previous lecture also I mentioned this calcite can be natural and or it can be induced uh, mm, induced by man-made activities also. You can search about microbially induced calcite precipitation. Microbially induced calcite precipitation. This is one. And second one is enzyme induced calcite precipitation. Enzyme induced. These two terms you can study how they are inducing the press by they are cementing these two weaker grains by using calcite. All right. So NaOH is not a cementing agent. Calcite is a cementing agent. All right. So naturally it exists, and artificially people are now trying to what to say, trying to induce this precipitation using microbes as well as chemical enzymes. All right. Any doubts? So moving to the next question. So which of the following sentences is not true? Which of the following sentences is not true? Which of loess are wind-blown deposits? Loess can stand in form of steep slopes. Presence of calcite in the loess makes it less suitable for construction activities. Loess are predominant in the arid and semi-arid regions. Which of the options is not true? Any answers? C and option D. See, loess are predominant in the arid and semi-arid regions. What is arid region? Arid region is essentially desert region, which are dry. As you already mentioned, loess are found in desert area, right? So that is known as arid region, which are completely dry. So loess are predominant in the sense they are found in arid and semi-arid regions, which is true. So whereas presence of calcite in the loess makes it suitable for construction activities, less suitable. So the presence of calcite uh, uh, in uh, in construction is actually if you use these sands in as aggregates in concrete or in what to say mortar, these things, it will be helpful as the presence of calcite will enhance the hydration process, right? So this is the false statement is presence of calcite in the loess makes it actually it makes it more suitable. The wrong option we are it's since it is the wrong option, no, it's a false option, then the option C is the right answer. Any doubts? Any doubts? Right. Coming to the next question, which of the following minerals lead to swelling and shrinkage of soils? Swelling and shrinkage of soils. Which of the following montmorillonite? right? So montmorillonite is more prone to swelling and shrinkage. So kaolinite, although kaolinite and halloysite are also clay minerals, so due to their arrangement, which you will be studying in the next week. So due to their arrangements, they are not prone to um, swelling, because kaolinite is montmorillonite. As far as montmorillonite is concerned, it is weakly the sheets, which are the mineral sheets, are weakly bound by only van der Waals force of attraction. All right, so that is the reason once water entered into this uh, once water enter into this in between these mineral sheets, it tends to swell. All right, so that is the reason why montmorillonite leads to enlarged swelling and shrinkage of soils. All right, yeah, that's what, high water absorption within the interlayer sheets. So that is the reason it tends to swell more. Right. So we'll take a short break. So we'll meet at exactly 6. So it's a small emergency. So I will just be right back. We'll meet at 6. Okay. So welcome back. Somebody is joining. So try to come on time to the person who has joined now. So please try to join by 5 so that you don't miss uh, you don't miss the session. It's already half of the session is gone. So coming to the next question, question number 11. Which of the following is or are transported soils? Which of the following is or are transported soils? Answers? Yes. So aeolian soils are, so coming to the options, aeolian soils are wind, wind transported soils. Marine deposits
Water,
are
transported by water.
water. So how marine deposits are formed? Any idea? How marine deposits are formed? These marine deposits essentially not only confines to the deposition at the sea, it also includes the deposition at the, what you call as estuary or something. So once the river with some velocity meets sea with some wave velocity, all right. So the water moving here and here will cause a sudden disruption in the flow. So and the velocities at this contact point suddenly tends to reduce, right? So several suspended particles which are carried by the water, which are suspended in the water and are being carried by it, will get deposited due to the sudden loss in velocity here. So hence these deposits also contribute majorly to the marine deposits, and these are essentially they give rise to what to say uh, essentially these in coastal areas where you find marine clays, so and marshes, so there they deposit like this. So that's how marine deposits are formed. Volcanic soils are usually broken down from cooling of magma. So that is essentially it's not a transported soil; it's a residual soil. And muskeg is usually bogs. What do you mean by bogs? Bogs are, it's like marshes. It's essentially more organic in nature. So, so it's organic in nature, and essentially they are formed by decomposition of uh, organisms, right? So that is also a residual soil. So it decomposes at the spot only. So hence the transported soils are essentially aeolian soils and marine deposits. Any doubts? So coming to the next question, soils and marine deposit. What are all its properties? Soils and marine deposits. So soils and marine deposits. So let us analyze the options. So marine deposits contain only inorganic matter, which is obviously not true, because once you are getting into marine, obviously there will be the components which arise from the decomposition of the dead marine organisms. So that is not true. Or low in moisture content, which is again not true, because essentially it is under the water environment. So it's high in moisture content, which is also, hence it is not true. Or insensitive soils. Or insensitive soils. What is sensitivity? What is sensitivity? Yes, you are right. Suspension in seawater, it has high water absorption and generally fine particles. You are true. You are right. So, any idea what is meant by sensitivity of soils? What is meant by sensitivity? To put under layman's term, sensitivity is so sensitivity is a ratio. All right. So the ratio between the strength of the soil at undisturbed state and strength of the soil under disturbed state. So this ratio is called sensitivity. So these marine deposits are usually what happens, they are under marine environment, which obviously tell that it is bounded by salts. So some salts are present between these soil grains. Once you touch it, or once if any disturbance occurs to it, the salts get dissolved, or there is a very high chance of the soil getting disturbed. And once it is disturbed, it loses its strength. It collapses completely. So especially marine deposits are especially very are highly sensitive. All right. So they are highly sensitive soils. So that is what sensitivity is. And disturbing in the sense, it is known as, it is also called as remolding. It is also called as remolded. Remolding. Right. So some clays possess property of thixotropy. What do you mean by thixotropy? Have you come across this? Have you come across this term, thixotropy? So I will give you a brief idea what is thixotropy and how it is related to the clays. So this is ideal definition of thixotropy. So what is it's as per the American Standard for Testing Materials, which is ASTM. So American Standard for Testing Materials. So thixotropy is a property of material that enables it to stiffen in a relatively short time on standing, but upon agitation or manipulation to change to a very soft consistency or to a fluid of very high viscosity, the process being completely reversible. So that's what I was saying. So some soils they possess high undisturbed strength. Once you start disturbing it, it loses its strength completely, and due to its thixotropic nature, it tries to regain its strength slowly. So bentonite is one of the best example for which exhibits thixotropic. So once you work with bentonite slurry, you once you work with it, it will be very sticky in nature and very what to say uh, it 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 tends to uh, have what is how to put it. So it tends to have a flow property, and once you leave it, it changes to highly stiffened. It changes to a highly stiffened form. So that is the property of thixotropy. Right. So clays especially exhibit this thixotropic properties. So it's just for your additional information. So you will study the thixotropic nature of soils in the coming weeks. All right. Any doubts? Coming to the next question. Bentonite is a material obtained due to the weathering of chemical weathering. Essentially, you can modify it as chemical weathering. Bentonite is a material obtained due to chemical weathering of which type of rocks? It's from volcanic ash. So volcanic ash. So that's why in the coast of western region of India, you find lot of uh, these minerals. Sorry, this type of clays: bentonite, montmolonite, black cotton soil, and everything, which is essentially chemical weathering of volcanic ash. So especially basalt. All right. So bentonite is material formed from volcanic ash. That's why the regions of Rajasthan and a part of Gujarat contributes. Yeah, exactly. It's found both in some parts of Gujarat and uh, Rajasthan. So they give bentonite. So where is bentonite used in usually? It's not waste material decomposition. So bentonite is usually used, as you said, it's one of the uses they use as a buffer material in nuclear waste repositories. So because it has a highly absorbing capacity, so that it can uh, absorb some what to say the especially heavy metals and everything. They are also place can also be used as some liner materials by mixing with some other uh, components, and especially bentonite slurry is used in oil well installations. So they use it as a uh, fuel to sorry, not as a liquid to flush out. Bentonite slurries are used, and also they are used as in in cements, well sealing cements. So in these cases, bentonite is being largely used. Any doubts? Right. So coming to the next question, which of the following soil is or are transported by gravitational force? Which of the following soils are transported by gravitational force? So loess, dunes and drift are essentially due to wind, and talus is from steep cliffs, especially steep cliffs. The soil that is getting disintegrated due to the fall from steep cliffs are talus. You are right. So coming to the next question. So lowest deposits are formed by lowest deposits are formed by yes. So lowest deposits are essentially formed by continuous flow of wind. It's a aeolian deposit. Again, as I mentioned, it's a aeolian deposit. Right? So the option is D. So question 16. The collapsible soil is associated with collapsible soil is associated with. It's not essentially loess. See what is uh, so first of all, we will try to understand what are all these deposits. Loess, as we already discussed, aeolian deposits. What are warped clays? What are warped clays? Warped clays. Okay. Let me explain what is Ward clays first so that you can understand what is it. So Ward clays are essentially alternate deposits of clay and silt. All right, clay, silt, clay, silt, etc. So essentially, these are found in what how to the so-called frozen regions. So and essentially frozen lacustrine region, that is lake regions. So how they are formed is, so let us consider, due to the seasonal variation, let us consider a water body, right, and a bed. All right. So now during during normal, that is during summers or spring where the water is not frozen, so what will happen? How clay and silt are differentiated? How clay and silt are differentiated? First, they are differentiated based on how are clay and silt differentiated? They are differentiated based on what? So fundamentally, it's due to particle size. So once, if you have a still water, what type of particles you have? One small particle and one big particle. Which particle will settle down first? It it is obviously it's going to be the big particle. So silt is relatively bigger. So during this season, silt will start settling, right? So and usually it's not only subjected to lake deposits. It's let us consider a moving system also. Usually, silt is getting deposited. Once the seasonal variation comes, once it is winter and a part of water is frozen, what happens to the velocity of the fluid flow? What happens to the velocity of the flow of water? It is going to decrease or increase. Velocity will decrease, right? So at that time, the smaller particles will also start settling. So this season, silts will start settling, and followed by some silt particles also will settle, followed by a layer of clay. So very fine particles will start settling. Again, other seasonal variation occurs, silt starts settling. So again, winter occurs, clay starts settling. So it forms an alternate layer of clay and silt, which is termed as Warwood clay. All right. So laterite soils are essentially red soils which are found in Western Ghats, right? So they are very loose deposits, uh, but the most collapsible of all nature is black cotton soil. So because of its high,
Swelling and sinkage for black cotton soils are
yeah,
right.
they are prone to heavy shrinkage and swelling. So due to the presence of montmorillonite. So the more collapsible soil compared to all these four is black cotton soil. So that is the right option. Any doubts? coming to the next question. Which of the following present in the soil is most helpful for the growth of plants? Which of the following present in the soil is most helpful for the growth of plants? C. Humus. So, so the growth of plants usually occurs. Sorry, is the nutrients are especially present in the topsoil. Topsoil is defined by top 100 mm of soil. So, due to the decomposition of several organic matters and living organisms, humus acids, humus gets the, what to say, they not it's 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 generally composed predominantly of humus. So humus, humic acid, and etc., which acts as a nutrient for plant growth. So most helpful for the growth of plants is humus. So which of the following is a pozzolanic material? Coming next question. Which of the following is a pozzolanic material? What is a pozzolanic material? What is a pozzolanic material first? How will you define a pozzolanic material? Is it only lightweight? What is the exact nature of pozzolanic material? Lightweight is right. Apart from that, what makes it stand apart from other lightweight material?
Sir, silica and aluminous material types.
Yes, what does it do? Okay, let me put it in this way. Why pozzolanic materials are most favored in cement and concrete productions? You have PPC, right? Portland pozzolanic cement. Why pozzolanic materials are used? They have the property of cementing property. That is true. It has an inherent cementitious property when it is mixed with water, and that property also enhances its reactivity with calcium hydroxide. So that is why it is being used in cement. All right. So in this, quartzite is a rock. Quartzite is a metamorphic rock. Shale is a sedimentary rock. Shale is essentially a highly compacted clay. Highly compacted, sorry, compacted clay. Limestone is a sedimentary rock. So volcanic ash is a pozzolanic material. So, so that is that was since it is very fine, it is lightweight as you rightly mentioned. It is comprised of silica and aluminosilicates, and it is relatively more. It possesses more cementitious properties. Right. Coming to the next question, metamorphic rock, that is formed as a result of high pressure is? Metamorphic rock due to the formation of high pressure, marble, right? Granite is a igneous rock. Shale is a sedimentary rock. Basalt is igneous or sedimentary or what type of rock? It is also igneous. But what is the difference between granite and basalt? What is the difference between granite and basalt? That is fine. I'm asking from uh, what to say, from a formation point of view. What sets apart granite and basalt? Will be just right back. Sorry. So as you now you have seen, I think, what is the difference between granite and basalt. So basalt is essentially due to the slow cooling of magma, right? So molten magma. So essentially, to there are two types of igneous rocks where the cooling occurs rapidly and cooling occurs very slowly. So where cooling occurs rapidly are volcanic rocks. Volcanic rocks. Where cooling occurs slowly are plutonic rocks. Right? So this granite comes under plutonic rock. Marble is due to the process called high pressure and high temperature, which is called as metamorphosis. Right? So shale is a sedimentary rock. As I previously mentioned, it's compacted clays, highly compacted clay, which is almost less porous and less pervious. Right? So shale is not an option. Granite is not an option. Basalt, as I mentioned, it's a volcanic rock which forms by rapid cooling. So hence that is also not an option. Which of the following is a freshwater lake deposit? Which of the following is a freshwater lake deposit? It's lacustrine deposit. Alluvial is a freshwater river deposit, right? It's a freshwater river deposit. And loess is a wind deposit. Lacustrine is a lake deposit. What about tuff? What about tuff?
Volcanic ash deposit something.
What about tuff? Am I audible? Yeah, tell me. Sorry.
Volcanic acid deposit something.
Yeah. So it's deposition of volcanic ash, right? So it's tuff. Deposition of volcanic ash. So it's tuff. All right. Now coming to the next question. See, now thixotropic property is exhibited by thixotropic property is exhibited by bentonite. We have discussed about thixotropic property earlier. It's exhibited by bentonite. All right. Coming to the next question. Black cotton soils deposits are formed from weathering of what type of rock? Black cotton soils are formed by the deposition of the weathering of granite is a igneous rock. Gneiss is a igneous rock. Basalt is also an igneous rock. Shale is a sedimentary rock. Basalt is formed by rapid cooling of magma, which is basalt, and chemical weathering of basalt results in black cotton soil, which is highly rich in what mineral? Highly rich in montmorillonite. Right? So it's highly rich in montmorillonite. Any doubts? I think it's again and again it's coming. Now it's a repetition, I guess. So coming to the next question, which of the following deposits is susceptible to liquefaction? Which of the following is susceptible to liquefaction? What is liquefaction? What is liquefaction? Yeah. So not only earthquake, due to sudden loading, there is a rise in pore pressures. So which you will learn what is pore pressure and everything. This one. So which will cause a sudden loss in shear strength, which will make the soil to behave like a liquid. It will lose its shear strength. So that is what liquefaction is. Liquefaction essentially occurs in soils which are deposited loosely, or what to say, uh, uh, loose sand granular deposits which are loose. All right. So that's what it's alluvial. Peats are organic. Laterite is essentially it's in layman term it's a red soil. Marine clay is a, as you know, it comprises of fine clay materials. And alluvial soils are deposited or predominantly sand deposits, and that's why alluvial soils are more susceptible to liquefaction. That is why the regions pertaining to Bihar and especially delta regions are prone to liquefaction on any instant loads. That's why the construction of bridges and everything, piers in these formations or in these region is very difficult. So uh, that's what liquefaction does. So one of the major deposits which are susceptible to liquefaction is alluvial deposits. All right. Now coming to the next question. Yeah,
हाँ नाम भी है ठीक ठीक है
please switch off your mic.
क्लास रूम में 10 मिनट बाद वो क्लास चलता है 7 बजे खत्म हो जाएगी
Please switch off your mic and
10 मिनट में खत्म हो जाएगी 5 से 7 लगा बस तोरे कॉलेज का हो नहीं PhD स्कॉलर योगेंद्र नारायण एस वो जन पीएचडी करत रहन। ना ना मतलब वो अभी क्लास लेत रहन। आईआईटी बॉम्बे सिविल इंजीनियरिंग डिपार्टमेंट से। हम्म,
कभी पढ़ते रहना।
हाँ 10 मिनट बस।
हाँ ठीक है, फोन करो।
ठीक।
Please switch off your mic. Right. Match the following. So A is wind. Wind is especially lowest deposits. Lake is lacustrine deposit. Gravity, it's talus. And glacier is till.
Till.
Right. So this is the right option. So coming to the next question. So based on the geological classification of rocks, we have limestone, shale, granite, and marble classified into three. Limestone is a sedimentary rock. Shale is also a sedimentary rock. Granite is an igneous rock. Marble is a metamorphic rock. Right? Any doubts? Any doubts? Okay. So coming to the next question, last question. So Loess is semi-arid region. Residual soil is muskeg. Transported soil is alluvial, and peats are organic matter. Right? So these are relatively simple questions. So with this today's session comes to an end. So now I would like to get your feedback on this session and how this session can be improved further. So you can express your ideas or express your suggestions to it. So whether you are happy with today's session or how can it be different, uh, or how can it be made better? Any suggestions? Yes. Anything? You can speak your mind. It's not an issue.
This session is very good for understanding the concept and for the exam right gate and or others that can help.
Anything you want to make the changes so that it becomes better? My pace and the way of
Sir,
speaking.
if you can a problem can solve that can be very good for us.
Yeah. So
Means numericals.
numerical part did not start yet, right? So it will be starting in another 1 or 2 weeks. So that's why I told you prior that first 3 4 weeks, most of it will be theory oriented. So once the classification of soil part starts, then we can solve some numerical questions. So that will be helpful for you. All right. That's what.
Yes, sir.
Yeah.
Thank you, sir.
Yeah. Thank you. So with this, we'll close the session. So try to be on time from the next session onwards. So and these sessions will be held every Saturday, 5 p.m. to 7 p.m. unless you are informed otherwise. So try to actively participate in this session and get benefited. And try to ask more questions be interactive in the class, sorry, in the session, and go through the weekly contents before attending these sessions. Right, that is the most important thing. So otherwise, you will not be able to get what is being solved or what is being discussed here. All right. So with this, I will close the session. Thank you.